Hi, I'm Patty Betzing. I teach math at Eastmont High School. Today we're going to be looking at inverse trig functions, and we're going to be really focusing on why we have to restrict the domain on the trig functions, on the inverse function. We're going to be able to find exact and approximate values of inverse trig functions or using them. And then we're also going to look at some composition of functions using the inverses. So we're going to start by looking at the sine function. So I have some graphs here. I couldn't get you to get these on your calculator without going into parametric mode, and I didn't want you to have to try to do all that. So I just put copies up here. So this is our sine curve. And the window for this one, I went from, my x value is going from negative 360 degrees to positive 360 degrees. And I think I put the y value is going from negative pi to positive pi. And then I use the same window here. And then on this one, my window goes from, for the x value, negative pi over 2 to positive pi over 2. And the y value has the same window, negative pi over 2 to positive pi over 2. Now you're probably going to want to sketch some of these graphs in your notes just so that you can refer back to them. So this is a graph of the sine function. So this is just sine of x, which you should be very familiar with. Okay. This one, I still have that sine of x function right here, but this darker function, or this, not a function, this darker curve that I have in here is the sine inverse of x. Now we've worked with sine inverse in the past, and we've used that when we were trying to find the angle measure when we're given the ratio. And right now we're going to be looking more at the function itself. So this is the sine inverse function. Now notice it's not a function because it doesn't pass the vertical line test. Before I go on, I have sine inverse. There's some other notation that you need to be familiar with. We use this to represent the inverse function. You will also see it referred to as the arc sine of x. And in some ways this is better because you're not tempted to think of this as being the reciprocal of 1 over sine of x, because that is not what the sine inverse of x is equal to. Okay, so that's very important that you know that this is not true. Okay, not true. So we've got two notations. They both mean exactly the same thing. They're completely interchangeable. If you prefer one over the other, you can rewrite every problem in the form that you like, and it will be totally fine. Okay. Now, since the sine function, this one here, is not one-to-one, we know that the inverse is not going to be a function. However, we work with this enough that we really would like to have it, to work with it as a function. So what we do is we restrict the domain of the sine function and then just look at the chunk of it. So what I want to do is find a portion of the graph, and they chose to go from negative pi over 2 to positive pi over 2. So they're just taking this portion right here. Okay. Now, when we think about that, they really could have taken different, I mean, they could have gone from here to here, or from here to here, but it wouldn't make sense to have it so far removed from the origin. So this one is nice because it goes right through the origin, and the inverse function just kind of right there with it. So here is just a zoom in of this. I just sort of zoomed in on this region right here, and that's what that looks like. So this graph here is the sine of x, and this graph is the sine inverse of x, or the arc sine of x. Okay. Now, the sine of x, when we talk about the restricted domain, the restricted domain is going to be from negative pi over 2 to positive pi over 2. That takes me from a range value, range value of negative 1 to positive 1. So if I'm looking on my graph, I'm starting down here, and I'm going up through all the sine values, and I'm moving around the circle until I get to positive 1. So I'm going from negative 1 to positive 1. Move around the outside of the circle here. -1 up to +1 for my range values. So when I look at the sine inverse, that inverse function, or the arcsine, remember when we're working with inverses that the domain and range switch. So for the arcsine, the domain is the ratio. So the domain is going to be from -1 to +1, and the range is going to go from -π/2 to +π/2. So if I look at this graph up here, this value right here is -π/2. This value right here is 1, -1, sorry, 0. This value right here is +1, and this value right here is π/2, which is about 1.6-ish, a little less, I mean. On this axis, this up here is +π/2. This value here would be 1. I have -1 and -π/2. So I have the graph of the two together there. Okay, so what we want to be able to do is use, and we've done this in the past, but if I tell you that the sine of x is equal to 1/2, then we know that the answer to that is 30 degrees. So if the height of this thing is at 1/2, I know that that gives me a 30-degree angle. Okay, so at 1/2, I should have about a 30-degree angle. So π/2, this should be about π/6. Okay. Now, we have to remember though that sine is also positive in quadrant 2. So we want to be able to refer to both of those when we need to, but when we're using the inverse function, it will always return a value somewhere between -π/2 and +π/2. And then we have to know about the unit circle enough to know that which other quadrants it's also positive or negative in. Okay, so let's look at a couple of these problems that should start making a little more sense. So I want to know where the sine of x is equal to 1/2. Well, I actually just said that, didn't I? So here's my unit circle, 1/2, and I know that this angle is 30 degrees, or π/6. Now, π/6 is one solution. There would also be another solution over here in quadrant 2, 5π/6. So when you type on your calculator the sine inverse of 1/2, your calculator is just going to return the value of 30 degrees or π/6. You have to know that there's another solution that you may have to find if they want all of them in a certain interval. Okay, so try this one. What would the value of x be? I want all the solutions for that one. Okay, when I solve these, I usually think of a unit circle. Sine is negative, so it's down here in quadrant 4. Draw a reference triangle. The opposite side is radical 3. The hypotenuse is 2. I recognize that as one of my special right triangles. Now, if I'm working in degree mode, this angle is -60. If I'm working in radian mode, it's going to be -π/3. Now, where else is the sign negative? I need to come over here into quadrant 3. So this would be another solution over there. Remember that this is also going to have a reference triangle of 60 degrees, and the numbers are just going to be mirror images of each other. Okay, so the sine value will be the same. So this angle would be -120 or -2π/3. So x can equal -60 degrees or -120 degrees. Now I could write those as coterminal angles and positive if I needed to. It depends on what we want. I could have written this as x is equal to 240 degrees and x is equal to 300 degrees. Same angles, but here they're positive. Now the calculator is never going to return these values to me because they're not in the restricted domain. So if I'm looking for an answer in this interval I'm gonna have to find those manually by adding on those integer multiples of 360 degrees or pi over 2 if I'm working in radian mode. Okay, so this is back from a previous class, but I just wanted to remind you of this. So when we were working with inverses last semester, we knew that if we took f of f inverse of x, it would always return x. And if I took f inverse of f of x, it would also return x. Okay, so if I compose the functions, I get x. Now, the same thing holds with sine and sine inverse, usually. So if I take the sine of the sine inverse of x, it's going to equal x. This will always be true. Now remember, this represents the ratio. It has to be between negative and positive 1. On this one, the sine inverse of the sine of x equals x. This is true provided that x is within the restricted domain. Now if I were to put something like 120 degrees in here, 120 degrees is not in the restricted domain, and so it's not going to give me a value of 120. So I'm going to put down one example that's not true here. So this is not true. The sine inverse of the sine of 120 degrees does not equal 120 degrees. So go ahead and let's type that in our calculator and see what we get. So I'll come over here to this calculator here. And we are going to type in, how did I write that? The sine inverse. So I go second sine inverse of the sine of 120. My calculator is still in degree mode. And if I hit enter, notice it tells me the answer is 60, not 120. Okay, so I'm going to go back over here to the document camera. And let's look at the unit circle here and see what is happening. So I started with the sine of 120. So I'm looking at 120 degrees, which is up here. Here's 120 degrees. Now, is this in quadrants 1 or 4? It's not. So it's not part of my restricted domain. So what I need to do visually, or to get through this problem, is I have to project or reflect this into quadrant 1, because I know that the sine value of this angle, which would be 60 degrees, because it's 180 minus 120, so it gives me 60 degrees. I know that 60 degrees will have the same sine value as 120 degrees. So I know that the sine inverse of the sine of 60 would be an equivalent statement, okay? And then this is going to equal 60. And that's why we're getting a different answer. So we're going to look at some examples, but that's just kind of what's happening here. So we'll spend more time on sine than we do with the other ones, just so we kind of can get a better grasp of this. So let's just look at a few of these together. So the first one says the sine inverse of the sine of pi over 4. So this is the sine of an angle, and is pi over 4 in quadrants 1 or 4? Is it within the restricted domain? And it is. Pi over 4 is right here, 45 degrees, pi over 4. And I know that the sine value of that is 1 over radical 2, or radical 2 over 2. And then if I do the sine inverse of that, I'm going to get right back to pi over 4 as being my answer. So on this one, the property works. The sine inverse of the sine, my answer was pi over 4, because pi over 4 was within my restricted domain, so I didn't have any problems. So let's look at this one. The sine inverse of the sine of 2. This one's in radian mode, so I have to think a little bit harder. But where is 2 radians? I know that 1 radian is about 57 degrees, so 2 radians is going to be over here somewhere. So if this angle right here is 2 radians, this is not within my restricted domain. So I'm going to have to do what I did on the last problem, and I need to reflect that over into quadrant 1, because these are going to have the same sine value. But now I need to find out what this angle is. Okay, now remember, on that last problem we did up here where I had the 120, it was just as simple as taking 120 and subtracting it from 180. Same thing is true when I'm working in radian mode. This angle right here is just going to be pi, which is the equivalent of 180, take away 2. So this angle is pi minus 2. So the statement sine inverse of the sine of 2 is equivalent to saying the sine inverse of the sine of pi minus 2. Now this one is within my restricted domain, so now I know my answer is just going to be pi minus 2 is my answer to that one. Okay, so on that one we had to move it to think of it being in the restricted domain. Okay, now look at this one. This one, since the sine inverse, I'm composing the sine of the sine inverse. On this one, I don't have to worry about the restricted domain like I did on the last two, but on this one, this is representing the ratio of the opposite over the hypotenuse. And is it possible to have a 2? No, we can't have a sine inverse of 2. So this is no solution. This is not possible at all. This number right here has to be between -1 and +1. So that one has no solution at all. Okay, so I look at this one. Is this value between -1 and +1? Yes. So I can go ahead and say that this is just going to be -1 over radical 5. So the ones we really need to worry about are when we have the sine inverse of the sine. On those, you really have to check that angle to make sure that it's within the restricted domain. If it's not, you just need to come up with the angle that has the same sine value either in quadrant 1 or quadrant 4, and it will be one of those. When it's written this way, you just need to make sure that this value is between -1 and +1, a possible ratio of sides. Okay? All right, so let's look at the cosine. This will go a little quicker now because it's very similar. So this is harder to see. So this curve right here is your cosine curve, which you should recognize. This is the inverse relation. Not calling it a function right now because I have it graphed where it's not doesn't pass the vertical line test. Same thing is true with the cosine function. I need to find a branch of my curve that covers all the range values, so I want to restrict the domain. Now when I look at this, I mean I could go from here to here or from here to I could pick any of those. Now this one doesn't go through the origin like -pi/2 to +pi/2 like we did with the sine function, because that only covers the positive values of cosine. So I want to make sure I go from -1 to +1. So probably the most reasonable choices would be to use these two, but then it's always negative angles, or to use these two. So we tend to choose, or we don't, some mathematician chose this branch. Okay, so that's the one we're going to use. So that is this piece right here. It goes from -1 to +1. Or I'm sorry, from +1 down to -1. And then when I take the inverse, it kind of snakes up like that. Okay, so this graph again, this value right here is -1 to +1, and this over here is pi, and I went up to pi. So that's the window for that one. Now, on that one, for cosine, I know that the cosine takes on all of its values as it moves from quadrant 1 into quadrant 2. So it starts at +1, goes to 0, and then it goes through the negative values to -1. So cosine will be in quadrants 1 or 2. So similar to sine, if it's in one of these quadrants, I just have to reflect it to find the value from either 1 or 2. Okay, so let's look, we'll look at a couple, or one anyway. Let's look at the cosine inverse of radical 3 over 2. The cosine inverse of radical 3 over 2. So I know that this is positive. So I'm looking in quadrant number 1, which is up here. Okay. So radical 3, so 1, 2, radical 3. So the cosine of radical 3 over 2 is this angle of pi over 6, or 30 degrees. So if you type that in your calculator, you're just going to get 30 degrees. If you're in radian mode, it will be the decimal approximation of pi over 6. Okay, so let's try a couple of these. Now similarly, like with the sine, it can be written as arc cosine instead of the cosine to the -1 or the cosine inverse. So for this one, arc cosine, so can the ratio be 2/3? Yes. So if I take the cosine of the cosine inverse or arc cosine of 2/3, I'm just going to get 2/3. So this one, the domain has to be between -1 and +1, which it was, so everything's okay. So this was my domain. So everything was fine on that one. Now let's look on this one. Notice the cosine inverse of the cosine. So this is the one where I have to consider my restricted domain, which in this case needs to be from 0 to pi, 0 to 180. So on my circle, I'm looking for 4 radians, and I think that 4 radians was like about 229 degrees. So it's clear down here in quadrant 3, down here somewhere. So here's 4. This is 4 radians. Now, is it in my restricted domain? No. So I need to reflect this up into this quadrant. Let me draw a circle here. I need to reflect this up into this quadrant. Okay, so what I need to do is find this angle, because this angle here and this angle here would be equivalent, and they have the same cosine value, and this is it within the restricted domain. So for this one, I want to take 2 pi minus 4, and that's going to give me this angle right here, this the measure of that angle. So I'm going to rewrite my problem. So I started with cosine inverse of cosine of 4. I'm going to replace this with the cosine inverse of the cosine of 2 pi minus 4. And this is within my restricted domain. So the answer is going to be 2 pi minus 4. So always think about what your possible domain is, and you have to adjust it if you need to. It's a lot easier with degrees. That's why I did the ones with radians, because they're harder to figure out. But the degree ones are a lot more intuitive because they're simpler to work with. Okay, so now we're going to look at the inverse tangent. So on the inverse tangent function, the first graph here is just your basic tangent. Okay, remember that this is your calculator making that jump. It's really an asymptote, so this line is not technically there. On this one, I've just restricted the domain down. So for this one, I'm going from negative pi over 2 to positive pi over 2. And that will give me one full branch of the tangent function. And then this darker one that's kind of flipped over sideways here, this is the tangent inverse function. So let's look at the domain on this one, because it's different than sine and cosine. The domain on this inverse function of tangent inverse, the domain goes from negative infinity to positive infinity. I'm going to put anything in that I want to. The range for the tangent inverse goes from negative pi over 2, no, I guess it doesn't include those, negative pi over 2 to positive pi over 2. Okay, so this one, for the domain, it can be anything. Okay, I'll write this down here. For the tangent of x, the restricted domain is from negative pi over 2 to positive pi over 2. And the range is from positive to negative infinity. Negative to positive infinity, sorry. Okay. So again, similar to the sine curve, we are working in quadrants 4 and 1. So the tangent takes on all of its values between negative pi over 2 and positive pi over 2. Okay, so let's try a couple of those, and then we will be done. Okay, so it starts off with this, a real simple one. The tangent inverse of negative 1. So where is the tangent, or what angle has a tangent of negative 1? I know that's over here in quadrant, this is the first one I think of, in quadrant 2. But I can't use the one in quadrant 2 because I have to be within negative pi over 2 to positive pi over 2. So the other place that the tangent is equal to negative 1 is down here in quadrant 4. So this angle is negative 45 degrees or negative pi over 4, depending on if we're working in radians or degrees. Okay. Now this one, 135 degrees. The tangent inverse of the tangent of 135. Is this within my restricted domain? It's not. So if I think of my circle, 135 is right here. And I need something in either quadrant 4 or quadrant number 1. Now be careful with tangent, we don't just reflect that over like we do with sine and cosine. On that one we actually send it this other direction. So this one comes down here and is negative 45 degrees. And this number I can use, so I want to rewrite that as the tangent inverse of the tangent of negative 45. And now I can undo that and get negative 45 degrees. Okay. Now look at the last one here. Tangent inverse, the tangent of the tangent inverse of radical 7. That's within my domain, so I know my answer is just going to be radical 7. And we're done. So when you try these, be very careful about which quadrant you're starting in, and then decide if you need to manipulate that to get within the restricted domain that you have to do the problem in. So always check your angle. I like making little unit circles and actually putting the angle on there. If it's not in here where it's supposed to be, I just find the corresponding angle in a different quadrant and then rewrite my equation to get my answer, and that seems to work pretty well for me. So try these, be sure and be checking your answers with calculators. This is a really good opportunity for teachers to give you a no calculator test, so make sure that you can do these without just typing them in. And good luck with those.